How Codebase is used in Java RMI, downloading Java RMI stubs in Java remote method invocation. Now we are considering how Codebase is used in Java RMI. Here you can see downloading Java RMI stubs. Using Java RMI, applications can create remote objects that accept method calls from clients in other VMs. In order for a client to call methods on a remote object, the client must have a way to communicate with the remote object. Rather than having to program the client to speak the remote objects protocol, Java RMI uses special classes called stubs that can be downloaded to the client. That are used to communicate with make method calls on the remote object. The java.rmi.server.codebase property value represent one or more URL locations from which these stubs and any classes needed by stubs can be downloaded. Like applets, the classes needed to execute remote method calls can be downloaded from file :// URLs, but like applets, a file : // URL generally requires the client and servers reside on the same physical host unless the file system referred to by the URLs made available using some other protocol such as NFS. Generally, the classes needed to execute remote method calls should be made accessible from a network resource such as HTTP or FTP server. Remote objects code base is specified by the remote object server by setting the java.rmi.server.codebase property. The Java RMI server registers a remote object bound to the name, and with the Java RMI registry, Codebase set on the server VM is annotated to the remote object reference in the Java RMI registry. Java RMI client requests a reference to a named remote object. The remote object stub instance is what the client will use to make remote methods calls to the remote object. 3. The Java RMI registry returns a reference, the stub instance, to the requested class. If the class definition for the stub instance can be found locally in the client's class path, which is always searched before the code base, the client will load the class locally. However, if the definition for the stub is not found in the client's class path, the client will attempt to retrieve the class definition from the remote object's code base. 4. The client requests the class definition from the code base. The code base client uses is the URL that was annotated to the stub instance when the stub class was loaded by the registry. Back in step 1, the annotated stub for the exported object was then registered with the Java RMI registry bound to the name. 5. The class definition for the stub or any other classes that needs is downloaded to the client. Note step 5, 4 and 5 are the same steps that the registry took to load the remote object class. When the remote object was bound to a name in registered the Java RMI registry, when the registry attempted to load the remote object stub class, it requested the class definition from the code base associated with that remote object. 6. Now the client has all the information that it needs to invoke the remote method on the remote object. The stub instance acts as a proxy to the remote object that exists on the server. So unlike the applet which uses the code base to execute the code in its local VM, the remote RMI client uses the remote object's code base to execute code in another potentially remote VM, as illustrated in this figure. Using Codebase in Java RMI for more than just stub downloading here. In addition to downloading stub and associated classes to client, the java.rmi.server.codebase property can be used to specify location in which any class, not only the stubs, can be downloaded. When the client makes method call to a remote object, the method that calls could be written to accept no arguments or a number of arguments. There are three distinct classes that may occur based on the Java data types of the method arguments. The first case, all of the method parameters and return values are primitive data types, so the remote object knows how to interpret them as method parameters, and there is no need to check class path or any code base. The second case is that the remote method parameter or return value is an object for which the remote object can find the class definition locally, its class path. In the third case, shown in step 6, in this figure, the remote method receives an object instance for which the remote object cannot find the class definition locally in its class path. This type of remote method call is illustrated in figure 4 here. This figure. The class of the object sent by the client will be a subtype of declared parameter type. The subtype is either an implementation of the interface that is declared as the method parameter or return type, a class of the class that is declared as the method parameter or return type. You can see here Java RMI client making a remote method call passing an unknown subtype as the method parameter. And here is step 7, like the applet code base, the client specified code base is used to download remote classes, non-remote classes and interfaces to other VMs. If the code base property is set on the client's application, then the code base is annotated to the subtype instance when the subtype class is loaded by the client. If the code base is not set on the client, the remote object will mistakenly use its code base. Here you can see a server that exported a remote object here. Server registers a remote object bound to a name. Here step 1 is connecting a server that exported remote object, and here the java.rmi.server.codebase equal this address, and it's connected to server that registers a remote object bound to a name. And here step 2, RMI client is connected to RMI registry via client makes a naming.lookup call. Here step 3, RMI registry is connected to RMI client via the registry returns an instance of the remote object stub. Here RMI client is connected to URL location and my host here via client requests the stub class from the code base. Here my host or URL location here is connected to RMI client via HTTP server returns remote objects stub class. Here my host here URL location interacts with RMI registry. Here step 6, RMI client is connected to remote object instance via makes a remote method call. Here you can see RMI registry, and here server that exported the remote object. Here is step 6, here RMI client is connected to remote object instance. Clients make a remote method call passing a subtype unknown to the remote object as a remote method parameter. And here RMI client interacts with URL location here. Here you can see the code base and via code base property. Here remote object instance interacts with URL location via remote object downloads the subtypes class definition from the client specified code base. Now this is the end of my presentation. Thank you very much for watching it.